All right, guys. So in lieu of me not being in class, you will be listening to today's lecture through this video. So we're going to talk about the periodic table. Like I told you, we already kind of introduced it. We're just going to keep learning a little bit more about it. So as many of you saw with your projects, Dmitri Mendeleev is the person that we can thank for creating the periodic table. And this was his first, his rough draft of what he thought it should look like. Obviously, you can see that this is clearly not what it looks like today at all, but it has the same concept, right? It follows the same concept and it's based on atomic weight. Again, you can see that here, another example. He was Russian. And this is what the modern table actually looks like. And this is just another example from his notebook, just so you could see. And so what he did is that he placed all those elements in order of increasing atomic mass. So as many of you saw, and like some of you made this comment, yes, as you go down the periodic table, you're going to see that the elements not only increase in the atomic number, but they also increase in their mass. So like it says here at the beginning, the periodic table wasn't fully completed. There was a lot of space left because obviously not all the elements had been found. But it was a pretty good rough draft of what it should look like. And eventually, obviously, as people found elements, they continued to add more and more to it, and it became what it is today. So here you can see germanium, gallium, and scandium. These are different metals that you can see on the periodic table. And so, as it says here, by 1886, all of the 3 elements had been fully discovered, and so we were complete. So there are some problems that were found with his idea of what the table should look like, and that was that not all the noble gases had been found, and I will show you in today's class what that even means. So we actually had that in 1984, we had the first noble gas that was discovered. And like I said, you guys will know by the end of today's class what that noble gas is. But this was actually very groundbreaking because this this created the discovery of a brand new class within the periodic table. And you guys are going to see today that there are different classes in the periodic table. So iodine and tellurium, as it said before, this was one of the oddities of the periodic table. And the issue was that in their placement on the periodic table, right? So tellurium, as you can see here, had a mass of 128 and iodine had a mass of 127. And like we said, we have it placed in order of increasing atomic mass, but here that was a little bit of a hiccup, right? We have tellurium with 128 and iodine with 127. So this is where Henry Moseley comes in. And like you guys also talked about in your experiments, he contributed greatly to the periodic table. Mendeleev is the one that established the period, that created it, and Moseley is the one that contributed to its completion, right? And he is the one that said that we should, instead of arranging it in terms of atomic number, instead of arranging it in terms of atomic mass, we should arrange them in terms of atomic number. And that's why when you look at the periodic table, you see that you go from 1 for hydrogen, 2 for helium, 3, 4, 5, 6, 7, etc., etc. So through his experimentation, we were actually able to see that the atomic number is equal to the nuclear charge. And like we said, that the atomic number is what determines the number of protons. And this is what came to be known as the periodic law. And this is that the physical and chemical properties of the elements are periodic to their functions of their atomic numbers. So we're going to go a little bit more into periodic law. This is what we just defined. But what exactly does that mean, right? Well, this just basically says that as the number of protons increase, there are certain properties that are going to change within the atom, right? For example, the number of valence electrons are going to increase, right? Because the more protons you have, like we said in a neutral element, the more electrons you are going to have. So this is just a little bit of a tidbit that Moseley left Oxford to enlist in the Royal Engineers, and he was killed by a sniper. So this is the periodic table. And as you can see, there are 92 naturally occurring elements. But obviously, look at how many we have. As of right now, we have a total of 118. So you can see down here, because I was asked this the other day, these are called the lanthanides and actinides. And these are a subsection of the periodic table. So if we were to include this, the periodic table would actually be much longer. However, we don't include these there. We just put that little break there, and then we put these at the bottom just for, stylistic purposes, so that it's easier to read. So elements are organized horizontally in rows, and the special name for this is called periods. So whenever we say periods, we're talking about the rows on the periodic table. And the length is determined by the number of electrons. So what does that mean, right? I'm going to show you with the periodic table. And this is something that's very important, is that all elements on the same period have the same number of electrons, right? Valence electrons. So let me go back so I can show you what that is. So this is what we call a period. And then this is what we call a group. When they're arranged vertically in a periodic table, they're called groups. And what's important about groups is that they share those similar chemical properties. So for example, this is going to be a group. Oh, let me show you this way. So that's what we call a group. And like it says there, if you guys are all part of the same group, that means that you guys all have similar physical and chemical properties. Then these are going to be what we call rows, okay? And rows is going to be like 1, 2, 3. And this tells you the number of valence shells that it has, right? So for example, if you're on this, if you're a hydrogen, this is what the hydrogen atom would look like. Just one shell. And same for helium. If you're lithium, that means that you would have 2 shells. Why? Because it's in the second row. But in sodium, as you see here, sodium is in the 3rd row. So can you guess how many it would have? It would have 3 shells. So the number that's here on the side of the periodic table, that determines the shell size that it's going to have. And another important tidbit is that the elements in the groups have the same number of valence electrons. So the valence electrons, what they're going to be is that every atom is going to have shells, right? That outermost shell, or that last shell, is going to be called the valence shell. And on the periodic table, what you're going to see is that depending on the group that you are in, that is going to tell you how many valence electrons you have. So let's go back over here, and I'm just going to erase this. So let's say this corresponds, you're going to number these the same way, right? So here we have group 1. Here we have group 2. And here, if you can see, we have group 3, group 4, group 5, 6, 7, and 8. So let's say I am in group 3. So I'm going to be group 3. How many valence electrons do I have? So for valence electrons, I would say I have 3 valence electrons. How many shells do I have? Right? How do we find that out? Remember that we said that the numbers here on the side are going to correspond to the number of valence shells. So if I'm in row 2, as you can see here, and I'm talking about specifically boron, that means that I'm going to have 2 valence shells. Not 2 valence shells, 2 shells. So what will my boron atom look like? We're going to have that center. We're going to have 1, 2 shells. And then on the outermost shell, I'm going to have 1, 2, 3 valence electrons. And there's a little bit more that goes into this, but this is just the basics of how we know the valence electron, the number of valence electrons, and how we know how many shells the atom has. But a little bit more is going to go into this. And I'm going to show you how to draw this on your own and all that stuff. So as you can see, I go into it here. The valence electrons are just going to be the outermost electrons. So like it says here, you can see the numbers, like I told you, on the periodic table that I'm going to give you. These are going to be numbered, but just so that you can know a little bit better, you can number it yourself. Some important things that you should know is that the periodic table is going to be divided into different blocks. And for example, you're going to have the S, the P, the D, and the F block. For now, all you have to know is that these blocks exist, and I will show you in the following classes how we use these designations and what they mean. We use these for what is called the electron configuration, which you guys will learn, and it will be fun to do. So let's just try to fill this in, right? So if we know that we're in period 1, we look over here and we check, okay, we're in period 1. Remember that we said period is going to be that. So how many elements do we have? Well, we have a total of 2 elements in the period. And we can see, for here, right, we have 1, 2 elements. So I'm going to show you a little bit more about what this means. I'm going to skip this because I want to show you in a specific way how you know that, how to do this. But for now, you just become acquainted that this is what we're going to be doing in the few following classes. We're going to be learning about electron configuration and a little bit more about the different classes on the periodic table.